If you've been tracking the AI world, you know that agents like Copilot and Gemini are getting profoundly good at writing code.
Oh, absolutely. The code generation is incredible.
That's just the first step, right? The reality of modern web development, the part where that code actually has to run in a messy live browser, that's where things, often fall off the rails.
That is the core challenge. I mean, how does the AI actually test that new JavaScript function it just wrote?
Right.
How does it debug some tricky rendering error that, only happens on a specific screen size?
Yeah.
Or analyze a performance bottleneck? It needs a skeleton key, really, to the whole browser environment.
And that skeleton key is exactly what we're focusing on in our deep dive today. We are bypassing the usual stack of articles, and we're looking at one single super specialized source.
That's one.
Just one. The GitHub repository for a tool called Chrome DevTools MCP. This isn't some theory. It's a real utility, giving AI assistants full actionable power over a live Chrome browser.
Okay, so our mission here is to define what this bridge actually is and I guess why it's such a big deal for AI development.
Let's start there. What is it?
So the name itself gives us a clue. MCP stands for Model Context Protocol. And this tool, Chrome DevTools MCP, is the server that implements it. Its whole purpose is to give the AI model the context it needs.
Context like what?
Like reliable automation, deep debugging tools, and really robust performance data. And it does all of this by tapping directly into Chrome DevTools.
And just looking at the GitHub repo, the engagement is huge. This thing is clearly where the action is.
It really is. We're talking over 19,500 stars, 1.2 thousand forks. Developers are paying very close attention to this.
It's foundational infrastructure at this point.
Yeah, it's becoming the standard. And for anyone listening who wants to just, jump in and try it, the prerequisites are pretty straightforward. You just need a recent version of Node.js, stable Chrome, and NPM, all standard developer tools.
Okay, so let's unpack that. The AI agent connects through this server. Then what? What does full browser control actually look like?
Well, the functionality is broken down really neatly into categories they call tools. And get this, there are over 26 specific functions the AI can use.
26. Wow.
Yeah, think of it like a really sophisticated API for the browser that lets the AI operate not just at the code level, but at the whole user experience level.
So what are some of the most critical tools it gets?
Okay, so let's start with automation and input. This is all about reliability. The source says it uses Puppeteer, which is known for being super robust.
So it won't fail just because a page is still loading or something?
Exactly. It makes sure the actions mimic a human user perfectly. We're talking click, drag, fill, and fill form.
But it's got to be more than just simple clicks.
Oh, way more. It handles all the messy stuff we developers hate to script. Like press key for keyboard shortcuts, hover for those complicated menus.
Okay. And then the really tough ones. Upload file and handle dialog. Wait, so it can handle a native OS file picker and then a JavaScript alert box?
All autonomously. It can complete a whole multi-step form, upload a resume, click OK on the confirmation pop-up, all by itself.
That alone makes it a world-class QA tester right out of the box.
You got it. Then there's navigation. You have their basics, close page, new page, navigate page.
Sure.
But the killer tool here for building stable tests is wait for. It lets the AI pause until a specific condition is met.
Like waiting for a certain element to appear on the page?
Exactly that. Or for a network request to finish, or even for JavaScript variable to change. It removes all the guesswork.
And since it's tied to Chrome, can the agent, pretend to be a different device?
Yep, that's under emulation. It can use emulate to change things like device type, language, time zone, and resize page to test responsiveness across different viewports. Mobile, desktop, tablet, you name it. Okay, now this is where I think it gets really interesting. Moving beyond just testing if things work, into the realm of senior engineering. Performance. This is where the AI starts to analyze the deep technical health of the app. There are 3 powerful tools here. You know what? It can use performance start trace and performance stop trace to record the deepest possible performance data from DevTools. We're talking CPU usage, paint times, garbage collection events, everything.
But just recording raw data isn't that smart. It's interpreting it that's hard.
Precisely. And that's the third tool, Performance Analyze Insight. The AI doesn't just get a giant JSON file of timings. It gets actionable insights directly from that trace. So it could say, hey, this function blocked the main thread for 500 milliseconds. That's exactly it. It identifies the long task and flags the specific function call that caused it. This is the whole point of the context in the protocol's name. It's not just what happened, but why it was slow. That's a game changer.
And for the bread and butter of debugging, just seeing what went wrong.
That's covered under debugging and network. The AI can see the entire network stack with get network request and list network requests. It sees every API call, the latency, the response codes.
And visually.
It can take screenshot and take snapshot,
Yeah.
and it monitors the runtime with get console message and list console messages.
Pulling those console messages is another great example of feeding real-world context back to the agent. It can see an error that didn't crash the page but might be confusing a user.
It gets the full picture of the application's health, but I think the single most powerful tool in this entire stack is its ability to just execute code directly.
Just
evaluate script. The AI can write and inject any JavaScript it wants directly into the live page.
So if it finds a bug, it doesn't just report it.
It can immediately test a potential fix. You can run a script to change the DOM or update a state variable and see if its hypothesis was correct, all in real time. That is deep active control.
That level of capability really explains why it's not some niche tool. The integration list is, well, it's basically every major AI coding environment out there.
It is. The documentation lists AMP, Anti-Gravity, Claude Code, Klein, Codex, all the Copilot versions, Cursor, Gemini, JetBrains AI Assistant, Juni. The list just goes on.
So if you're using an AI coding assistant, there's a very good chance it can talk to this tool.
A very high chance. This is becoming the standard way for AI to interact with the web.
Okay. Now, before we get into the setup, the documentation has this very specific disclaimer, a warning we really need to spend a moment on.
Yeah, this is the part where everyone should pause and really think about the amount of access we're talking about.
What does it say?
It says explicitly that Chrome DevTools MCP exposes the entire content of the browser instance to the clients, meaning they can inspect, debug, and this is the critical part, modify any data in the browser or diff tools.
Wait, hold on. Modify any data. So if I'm running this on, say, a logged-in staging environment, the AI could run a script that changes my user settings, or worse.
That is precisely the risk. You are handing over the keys to the entire session state. That's cookies, local storage, your sign-in status, anything visible on the screen.
So the takeaway here is, be very, very careful. The official advice is clear. Avoid sharing sensitive or personal information you don't want the AI to see when running this server. You have to treat the agent like a trusted person sitting at your computer. That context is absolutely essential. Okay, so assuming you're testing non-sensitive code, the basic setup sounds pretty simple. It is. Just ntx Chrome DevTools MCP at latest. Standard node command. And there's neat detail. It doesn't start Chrome right away.
Ooh, it only starts the browser once the AI actually uses a tool that needs it, like navigating to a page. It's smart about conserving resources.
That is smart. Okay, let's pivot to the advanced connection strategies. The default starts a clean, isolated profile. But, thinking about real-world developer problems, why would you need to connect to an already running Chrome instance?
There are really three critical reasons. The first is just maintaining application state. Imagine you're manually clicking through a long sign-up flow and you hit a bug on step 5.
Right, you don't want the AI to have to start all over from step 1.
Yeah, exactly. You want it to take over your current logged-in session and start debugging from right where you are.
Makes sense. What's the second reason?
Security measures. Some apps have security layers that can detect when a browser is being controlled by WebDriver, which is the default for a new profile. They might block logins.
So connecting to a manually started browser can bypass that. It often can, yeah. And the third reason is, well, it's a bit more technical. Sandboxing. Okay.
If you're running your AI client inside a secure container, that container might not have permission to launch a whole new Chrome process. So you need a way for the sandboxed agent to connect to a browser running outside its box.
Got it. So let's look at the first method for that, the automatic connection. This sounds like the one for sharing a session between a human and an AI. It's the most seamless, for sure. You have to go into Chrome and enable remote debugging first. It's at chrome.inspect-chag remote debugging. And then you just run the server with a flag.
Yep. Just add the autoconnect argument.
Does that give the AI immediate silent access?
No. And this is a really important security feature from Chrome. The browser will pop up a big dialog box, and the user has to physically click Allow to grant permission.
So the browser itself acts as a gatekeeper. You always know when something is trying to take control.
Always.
Yeah.
The user is always in the loop. Okay, what about the second method? Manual connection via remote debugging port. This sounds like the one for sandboxes, but also the riskiest. It is. This is what you use when the server just can't launch Chrome itself. You tell the server where to connect with an argument like browser URL pointing to a local port. like 9222.
And what are the absolute must-do security steps for this?
First, you have to close all other running instances of Chrome. Then you start a new one from the command line with two very important flags.
Which are?
Remote debugging port 9222 to open the door. But for security, you must also use a non-default user data directory. Something like user data dir pointing to a temporary folder.
Why is that temporary directory so critical? Because it ensures your real browsing profile with all your saved passwords, your cookies, your personal data is never exposed to that debugging session. And the warning is repeated here very strongly. When that port is open, any application on your machine can connect and control the browser. So you have to be extremely careful and close it right after you're done.
Absolutely, especially if you're browsing sensitive sites.
So the workaround for sandboxes is also the biggest security liability. That's a serious trade-off.
It's the price you pay for autonomy in these lockdown environments.
Yeah.
And sometimes it's unavoidable. OS-level sandboxes, like on Mac OS or in Linux containers, will actually prevent the server from starting Chrome itself. So manual connection is the only way. So to quickly summarize this deep dive, we've looked at the Chrome DevTools MCP server. It implements the Model Context Protocol and gives AI agents deep, actionable control over web apps using the full power of Chrome DevTools.
Right.
From user simulation to performance tracing, network analysis, and even running its own code.
So what does this all really mean? What's the big picture here?
I think it signifies a really profound practical shift. AI is moving from being this brilliant but sort of theoretical programmer to an active autonomous tester and debugger. It's operating directly on live complex web apps.
It's no longer just writing the code. It's validating and improving the entire user experience inside the browser.
Exactly. The agent can now debug network timing issues or optimize how resources load tasks that used to be reserved for very experienced human developers.
Right. And that brings us back to that really powerful feature we talked about, the one that feels a bit explosive.
Evaluate script, the
Yeah.
ability to run any code it wants.
Yeah.
So given that the security disclaimer says the agent can modify any data in the browser or DevTools, here's the question. How quickly will developers shift from just asking an AI for code snippets to giving it autonomous, live access to their testing or pre-production environments, where real data is? That leap of trust from just reviewing code to allowing full live autonomy, I think that's going to be the next major hurdle in AI engineering.